Alright guys, so today we're going to have a look at how to identify algebraic rules from a table of values. In particular, we're going to focus on how to do this for one-step equations like you can see here. Now, what does a one-step equation mean? Well, it means something along these lines where you've got y is equal to x plus 2, or maybe y is equal to x take 5, because what you can see here is only one thing's happening to the x. Now that's an addition and a subtraction kind of example, and we could also have a multiplication and division example where you've got y is equal to 2x because you've got one thing happening to the x but it's being multiplied, or we've got y is equal to x divided by 4, for example, where once again it's just one thing happening to the x but we're now dividing it. So let's go through now and have a look at these tables of values that you can see here, and we'll pay attention to the addition and subtraction ones first of all. And as you can see here, we've got the first table where you've got x and y, and you can see it's going up by 1s here, and it's going up by 1s down the bottom as well. But what are we going to do to figure out what's actually happening? What's the pattern between the two? Well, what I recommend you do is you look first of all at the numbers going up the top here. Alright, let's have a look at 0, and if you have a look at 0, what's the number underneath it? Well, it's 5. So what have we done to get from 0 to 5? Well, let's just have a think about it. We've probably added 5. Now let's have a look here. If we go from 1 to 6, have we added 5 again? Well, yeah, that's worked. And 2 to 7, well, that's plus 5, and 3 plus 5 is 8, and 4 plus 5 is 9. So because it's the same thing happening every time from the top to get down to the bottom, we know that the rule is going to be y, our y value, that is anything along this line, will be equal to x plus 5, because to get this answer here along the y line or along the y row, we need to do our x value plus 5. That is, we do 0 plus 5 is 5. 1 plus 5 is 6. 2 plus 5 is 7. 3 plus 5 is 8. And 4 plus 5 is 9. So therefore this is going to be our rule. Our y row is equal to our x row plus 5. Now let's have a look at our table over here where you can see the D row and the C row. And what we want to do is come up with a rule to represent what's going on to get from the D row down to the C row in every case. So if we have a look here, it's always going to be our C row is dependent upon our D row. So therefore we write C out the front where the dependent variable goes. And that's going to be C is equal to. Alright, now let's have a think about what's happening to get from here down to here. Well, it's going to be 0, and if we get down to -3, I reckon it's going to be something along the lines of -3. Let's see if that works for all of them, shall we? So 0 minus 3 is -3. Yeah, cool. 3 minus 3 is 0. That works. 4 minus 3 is 1. Yeah, that works. 8 minus 3 is 5. Once again, it works. And 10 minus 3 is 7. So because it's the same thing every single time, we know that C will be equal to whatever our D value is minus 3. Because that's what you can see here. We're minusing 3. We minus 3. We minus 3. We minus 3, and we minus 3, and that will get us our answer below each time. So therefore, as you can see for this table, the rule is our C row, that is all of these numbers here, will be equal to whatever our D row is, minus 3. Now let's have a look at the multiplication division, shall we? And therefore, if we have a look here, we've got our A row and our B row. Now remember, our B row is going to be our dependent variable because our B will depend on whatever our A is. Now because B is our dependent variable, we're going to actually write B is equal to. And now what we need to do is figure out what's happening to get from here to here, here to here, here to here, etc. Right, that is to get from our A row down to our B row. So if we have a look, 0 down to 0. Well, we haven't added anything, have we, or subtracted anything because it's still at 0. 1 to 2. Ooh, maybe we've multiplied it by 2 because we haven't added anything, we know that from this one. But we've multiplied it, so therefore 1 times 2 is 2. Does that work for the rest of them? 2 times 2 is 4. 5 times 2 is 10. 7 times 2 is 14. So we know that we're multiplying everything by 2. That is, we multiply all of the top row by 2 to get to the bottom row. So therefore B is equal to 2 times whatever our A value is. Or in other words, B is equal to 2A because we don't need to write the times there. Alright, so let's have a look at this next one. We've got our S row and our T row. Now if we have a think about it, our T row is our dependent variable, so we write T is equal to. And then we're going to figure out, well, what's going to go here? 0 to 0, so we know that we're not adding or subtracting anything. Next one is 5 to 1. So to get from 5 down to 1 without adding or subtracting, what are we going to do? Well, maybe we divide it by 5. Let's have a think about this. Does it work for all of them? 10 divided by 5, is that 2? Well, yeah, it is. 15 divided by 5, is that 3? 20 divided by 5, is that 4? Well, yep, that works too. So because all of these to get from our top row down to our bottom row is divided by 5, we know that our T is going to be equal to our S row divided by 5. And there you have it. That's how we identify algebraic rules from a table of values for one-step equations.